So, what the heck is DNA replication? And what does it do?
DNA means deoxyribonucleic acid. In general, it makes you what you are.
Yeah, but how?
Oh my god, shut up! I'm getting to that.
Sorry.
You may know DNA as one of those twisted ladder things. That is called a double helix. But DNA is more than just a shape. It's made of various molecules, such as deoxyribose, or sugar, phosphate, adenine, guanine, cytosine, and thymine. This is a zoomed-in version of DNA. DNA is made of two strands. One strand is called a 3', and the other is a 5'. They both head in opposite directions. Deoxyribose and phosphate are found on the outside backbone of the DNA strands. The deoxyribose are those little green pentagons on the outside part. The phosphates are the purple, the outermost molecules in the DNA structure. The nitrogenous bases are hard to pinpoint on this diagram, so I'll show you a different one that contains purines and pyrimidines. Purines, such as the nitrogenous bases, adenine and guanine, both contain 2 carbon rings. The carbon rings are the hexagon and pentagon that make up the atoms in both molecules. One way to remember the purine group is that both molecules contain the word 9 in them, like adenine and guanine,
Although they are pronounced adenine and guanine.
Okay, now for pyrimidines. Pyrimidine nitrogenous bases are cytosine and thymine. Unlike purines, pyrimidines only have 1 carbon ring. An easy way to remember the pyrimidines is that they are the only nitrogenous bases that contain the letter Y in them. Now I'll explain the base pairing rules. Basically, adenine will always pair up with thymine, and guanine will always pair up with cytosine. That is because each row of the DNA columns can only fit 3 carbon rings. And as I told you before, the purines have 2 carbon rings, and the pyrimidines have only 1 carbon ring. Get it? An easy way to remember adenine to thymine, or A to T, is that it spells at. I love to rhyme. Guanine to cytosine, or G to C, you can tell because both the letters have a curve in their shape, G and C.
So what is DNA replication?
Aha! I'm getting to that, and you'll be amazed.
Okay.
Here we go! This is step 1 of DNA replication. This is the original strand of DNA. But be mindful, because the nitrogenous bases in DNA can be any length and in any pattern, as long as the base pairing rule still applies. One strand of human DNA can have around 80 million nitrogenous bases in it. Step 2. The DNA begins to split and create a DNA fork, which zips through like a zipper. Step 3. The lead strand is heading down one end of the 3' strand. It heads toward where the DNA fork is being pushed. Step 4. Now the lagging strand is moving in. It has to come from the opposite side. That's because the 3' and 5' strands have grown in opposite directions. The nitrogenous bases are put in groups called Okazaki fragments.
Ahem. But why does DNA have to replicate 2 different ways?
That's because both the 3' and 5' strands head and translate in opposite directions. Now for the last step. The two half strands of the original DNA have split and created two whole strands. This is called semi-conservative replication.
Wow, who could figure out all of this stuff in one lifetime?
Great question. James Watson, an American biologist, and Francis Theodore Harry Compton Crick, a British physicist. Together, they wanted to create a scaled structure of DNA molecules. They tried really hard to make it out of wire and cardboard, but that didn't work. In 1953, another British scientist named Rosalind Franklin had X-ray views of what DNA looks like. Although he wasn't given permission to view it, Watson had seen what the DNA X-ray had shown. From there, Watson and Crick were able to create a correctly structured DNA molecule. That's how they discovered DNA structure. Now that's the end. Also, I'd like to inform you that everything that we just taught you is not true.
DNA really comes from the DNA fairy, and you shouldn't even have to worry about doing this in biology, because the DNA fairy has everything cut out for you.
Just kidding!
Also, we are sorry if you have a headache or if your brains are leaking out because of this guy's incredibly high voice.
Could you just shut your face?
It's true!
I know.
And for that reason, I'll be doing the review. DNA is shaped like a twisted ladder, or a double helix. DNA is made of the following molecules: deoxyribose, or sugar, phosphate, adenine, guanine, cytosine, and thymine.
Okay, hurry up.
Come on. What? Uh-oh. Deoxyribose and phosphorus are on the outside of the DNA structure, forming the backbone of the DNA. Adenine and guanine are both purines, and their names end in the word 9. Cytosine and thymine are both pyrimidines and contain the letter Y in their names. Adenine combines only with thymine, and guanine only combines with cytosine. Next page. The nitrogenous group, purine, contains 2 carbon molecules, while pyrimidines contain 1. The nitrogenous bases are all combined by hydrogen bonds. Both DNA strands are facing in opposite directions, known as the 3' and the 5' strands. The direction of which either goes is not specific, only that they head in opposite directions. The lead strand heads in the direction of the zip in the DNA structure, placing separate bonds in a continuous pattern. The lagging strand heads in the opposite direction of the zip in the DNA structure and places parts called Okazaki fragments. DNA replication is known as semi-conservative process because it uses 2 DNA halves to make 2 DNA wholes. Thanks a lot for watching! I hope you learned a lot.
This movie was endorsed by Grant Garnsey.